Okay, magandang araw po sa inyong lahat. Ako po ang inyong lingkod, Architect Ryan J. Abelia. And now, we are discussing about the shear in beams. Okay, so we have the stress failure in beams. So in figure 1.A, it represents a simple beam with a uniformly distributed load over its entire length. Examination of an actual beam so loaded probably would not reveal any effects of the load or loading on the beam. However, there are three distinct major tendencies for the beam to fail. Okay. So first, there is a tendency for the beam to fail by dropping between the supports, and that is in figure 1.B, and that is what we call the vertical shear. Okay, and second, the beam may fail by bending. Okay, and that is in figure 1.C. And third, there is a tendency for the beam to slide past for each other in a horizontal direction, and that is what we call the horizontal shear. Okay, so we have the vertical shear. Vertical shear is a tendency of one part of the beam to move vertically with respect to an adjacent part. The magnitude of the shear force at any section in the length of a beam is equal to the algebraic sum of the vertical forces on either side of the section. So vertical shear force is usually represented by the capital letter V in computing its values in the examples and problems. Consider the forces to the left of the section, but keep in mind that the same resulting force magnitude will be obtained with the forces on the right. So to find the magnitude of the vertical shear at any section in the length of the beam, simply add up the forces to the right or the left of the section, and it follows that the maximum value for the shear for simple beams is equal to the greater reaction. Okay, so we have an example. We have a simple beam with concentrated loads of 600 pounds. 600 pounds is 2 feet away from RA, and 1,000 pounds 6 feet away from RB. So the problem is to find the value of the vertical shear at various points along the length of the beam. Okay, so since we have two unknowns, RA and RB, we're going to use the equation summation moment is equal to 0 and positive is clockwise. Okay. For example, if we have to solve for RA, okay, so our pivotal point is at point B. So the equation summation moment at B is equal to 0 positive clockwise. Okay, and that is 0 is equal to RA positive because the direction is clockwise times the moment arm, which is 12 feet, minus 600 pounds. Okay, 600 pounds negative because the direction is in counterclockwise, and that is 10 feet away from point B. Okay, so next force is 1,000 pounds negative, negative since the direction is counterclockwise, and that is 6 feet away from the pivotal point, which is at point B. So reaction A is equal to 1,000 pounds. Okay. So next, since we have now our RA, we can now solve our RB using the equation summation forces vertical is equal to 0, positive upward. So to solve for RB, 0 is equal to RB positive plus 1,000 pounds, again positive because the direction is in uh, is the reaction is in upward direction. And next is negative 600 pounds or minus 600 pounds, negative since the direction is going down, and 1,000 pounds negative going down the direction. So the RB is 600 pounds. Okay. Okay. So since we have now our RA and RB, we can now draw the shear and the shear diagram. Okay. So first we have at RA equivalent to V1. Okay, represented by let, uh, letter V. We have 1,000 pounds going up. Okay, so going up, so that is 1,000 pounds. Okay, so from A, 1,000 pounds going to uh, 600 pounds. Since our loads are concentrated load, so our line going to 1,000 pounds to 600 pounds uh, is a straight line since zero load siya. Okay, so zero load. Okay, from 1,000 pounds, since we have a 600 pound going down. Okay, so minus 600 pound, and that is equal to 400 pounds. Okay, from 400 pounds going to 1,000 pounds. Again, our there is no load, no. So since our loads are concentrated loads, so the line is a straight line or 0 degree. Okay, from 400 to 1,000. Okay, so from 400 pounds minus 1,000 pounds, and that is equal to 600 pounds. Okay, so from negative 600 pounds going to B, for the reaction B, again there is no load, so 0 degree, so the line is a straight line. Okay, okay, so from negative 600 pounds plus, okay, plus 600 pounds, which is the RB, positive because the direction is going upward. Okay, so that is equal to 0. We have to close the diagram. Okay, so this is now our uh, shear diagram, and our maximum shear is at 1,000 pounds at reaction A. Okay, so thank you very much. Maraming salamat po sa inyong lahat sa pakikinig, at sana po ay may natutunan kayo. God bless.